So next up, we have Matej and Oded. I mean, you've read the title yourself, so they didn't ask for any special introductions, so just a round of applause, everyone.
So, hi everybody. We're really excited to be here. Thank you for hosting us in the Amsterdam Observability Day 2023. My name is Oded. I'm leading the platform group at CoreLogix. With me, Matej, you probably know him. He's an expert in observability and cloud engineering. Today, we are going to take you on a tour on exploring the Delta Temporality in OpenTelemetry, and we see if that adds up. Our plan for today, for the next 20 minutes or so, talking about the history of the observability ecosystem a bit, diving into the OpenTelemetry spec in regards to temporality, cumulative, and Delta. From there, we'll do a deep dive into in practice with the SDKs, the collector, and probably your observability backends. And in the end, hopefully, we'll get to a conclusion or more of a confusion. We'll see. So let's start. So taking the observability ecosystem, we're talking about a few decades ago, where measurements started for companies. We see that companies are starting to be interested in measuring stuff. It can be things like counting. They're starting to count their operation behavior. It can be the time it takes, the number of calls that an application did to a database. It can be the application counting. We want to count the number of users that are currently connected to our website. And it can be more interesting metrics like the number of coffee cups that my employees drank today. And we are seeing things like timing. We want to time things. We want on the operational layer to be able to understand how much time it takes to a call to be done to a database. We want to be able to understand application ones, like the time it takes to buy a book on my website. And again, more interesting stuff like the time it takes to my colleague to drink coffee in the morning. And from there, we're seeing two traditions evolve. One of them is the StatsD tradition, and the next one is, of course, Prometheus tradition. Just to do a quick poll, how many of you are using Prometheus today? I guess most of you. How many of you are using StatsD? Nice, and there are a few that probably use both. Yeah. So talking about StatsD a bit, so it's a simple daemon. It basically aggregates data and send it to a backend after a specific time frame, mostly 10 seconds. It's run over UDP, fire and forget. We don't care about the data. We just send it really, really fast. And when it sends data, it's either send it in a gauge concept, which is the current value, or on a counter level, which is something like an increment from the previous one. And then we go to the Prometheus tradition, where you have HTTP client, and the Prometheus scrape it every now and then on a specific time interval. And it has a fully fledged server TSDB database. And today, it can be used as an agent mode, using a remote write to different backends. And Prometheus doesn't really care if it's a gauge or it's counter. In the end, it returns the current value. Now, the thing about it is that when we go to the OpenTelemetry specification, a new data model was emerged, and this data model basically say that we are talking about time series model, and we have sum, and we have gauge, and we have histogram, and exponential histogram, and so on and so on. And the big thing about OpenTelemetry is that they say that when we are using popular existing metrics data formats, those can be transparently translated into OpenTelemetry data models for metrics without losing the semantics or the fidelity. And specifically, or explicitly, they are talking about Prometheus and StatsD, where those formats explicitly satisfied. And in order to reach that, a new concept was emerged, which is temporality. So temporality in the end, or aggregation temporality, means that, or it defines how metrics aggregator reports and aggregated values. It basically describes how those values relates to the time over which they are aggregated. So when we talk about cumulative, which is how Prometheus behaves, the metric aggregator reports changes since the fixed start time, which basically means that current values of cumulative metrics depends on all previous measurements since the start time, while talking about statsd, which is more of a delta aggregation temporality, metric aggregator reports changes since the last report time, which with the values of delta metrics are only based on the time interval associated with the last or the one measurement cycle. Now, how does it look like? So when we are talking about delta, we're starting in T0 time. We have a request, and we finish up 1 second cycle. We see that we have a count of 3 points. And then we continue to the second cycle from from T01 to T02. We have one request. This request in a 1 second cycle is again being calculated, and we see that the count is 1. And then we continue to the next 1 second cycle, and we have another request and another request. So from T02 to T03, we have 2 requests, and so on and so on. The increment is based on the 1 cycle time frame. And while we are looking at the cumulative temporality, and sums in this case, we are talking about, again, the first 1 second cycle. We have a request, and we see that from time 0 to time 01, we have 3 requests. And then we have another 1 request in the next 1 second cycle, and we see that now we have 4 requests from T0 to T02, and go on till T05. Basically getting the current value in the end. I'll now head up to my colleague Matej to continue the explanation with a more specific example. Thank you.
Yeah, thanks, Oded. So just to kind of finish this, sorry, this is the right slide. Just to finish off, like a little more practical example, or we have like a representation of some pseudo representation of series. So how we would count, for example, HTTP requests differently with delta and cumulative. So I think it's rather self-explanatory. Again, we can think of this as happening in certain time space, so in certain intervals, T0 to T1, T1 to T2, and so on. And we have events happening during these intervals. And sorry, it seems like it's. We have certain events happening during these intervals, and now the question is, in those last 2 columns, we can see how we are reporting this. So when we are talking about delta, you will see that we will report only the changes that are relevant during that given time interval. So if we've seen a GET request that we responded to with status code 200, we will report this. On the other hand, as you see, for example, in the second interval, there are no requests incoming. So with delta, we are not reporting any new values, but with the cumulative count, we're still reporting the latest value of the counter. And again, if we have, for example, just 200 requests coming with status code 200, so we're on delta side, we would report this increment, but on the cumulative, we're adding it to the previous value, and again, we're reporting for both requests with status code 200 and 400. Now, what Oded showed and talked about, this was on the level of the whole stream. Now, let's look at the individual data points, and let's look at how time works in relation to data points in the OpenTelemetry data model or the specification. There are two time values that are connected with data points in OpenTelemetry. One of them we can call as a time of observation. The spec refers to this with like the technical name or the name of the actual field that we can find it in OpenTelemetry time Unix Nano. The second time we can refer to as a start time or start of a sequence time, and I'll explain a little bit what kind of sequence we're talking about. So we have 2 time values connected with the time point. with the data point. Now, talking about the time of observation, this is probably more common and more straightforward to understand, right? This is the time when the actual measurement happened, or we presume that it has happened. So this is like the decisive timestamp. This is the time that is attached to the data point that we have. This one is mandatory, so we should include it with every data point, obviously, because we want to know when the measurement occurred. Depending on which part of the spec you're looking at, you will find this called. Depending on which part of OpenTelemetry you're looking at, you can find this called. The field will be called time Unix nano, or simply a timestamp. And as the time tells us, this is like a Unix time expressed in nanoseconds. Now, the second time, which the spec refers to as start time Unix nano, this time value is less important to the individual data point, but it helps us to make sense of how data points relate to each other temporally in the data stream. So it helps us to make sense of how the data points align in time. So as I said, this is less important to the individual point, but important to understand how the data points are sequenced. It's not mandatory, but it's strongly recommended for, especially for sums and histograms. And the value is, again, expressed in Unix time in nanoseconds. So this second value is required to correctly build what spec refers to as unbroken sequences. So we can think of this as a space in the stream where the data points build a coherent sequence, and there are no kind of resets, overlaps, gaps. There are like no alignment issues between those points, as you've seen on the example of the sum, which Oded showed you, which showed like the ideal case where all of those time points aligned. So this is important to get the correct have the correct value for the counter, and maybe more importantly to be able to also calculate rates properly. How these points need to align. So this differs between delta and cumulative. Oded alluded to this already. So for delta, we will be looking to always align the time Unix nano, the start time Unix nano of the next point with the time Unix nano of the preceding point. And on the other hand, with the cumulative delta, all the points in one stream or in one sequence will have the same start timestamp, and they will just report different time Unix nano values. So let's move on to the actual practice, and I think this is what kind of where our interest in this topic came, and where we started to experiment with it and play with it, because we had some users who were using StatsD, and I was like, okay, what's this Delta Temporality, as someone who's coming more from the Prometheus tradition or Prometheus ecosystem. So I think this is where things got more interesting, and we started to look at the whole pipeline and started to think, okay, what's happening with the data temporality in different stages as we're going through the collector pipeline, and we're processing those data points, and how this can affect the temporality and the actual data, and how it comes out at the end of the pipeline, right? So I'll move from all of the different through all of the different components, from the client side all the way to the backends. So if we begin at the client side, obviously you have multiple options, which kind of protocols or formats you want to use to send the data to collector. So you can use the what we already mentioned, the traditional things that come from outside of the OpenTelemetry itself, like Prometheus, StatsD. I'll keep using these two as examples, since we mentioned them as the traditions from which we're coming. So here, there's really, although we can kind of think of them as having different aggregation temporality, the notion of temporality doesn't really exist in Prometheus or StatsD. It's not part of that format or protocol. So like we have no choice or we have no control over this. We're just sending the data. We're providing the data to the collector. Whereas if you decide to, or if you use instrumentation from the OpenTelemetry, if you use the OpenTelemetry SDK, this is native to OpenTelemetry. So you have the possibility to choose the aggregation temporality, and you can, so you have more options to configure this, and by default, according to the specification, OpenTelemetry will use cumulative temporality, but you can switch this to Delta. Now then we move on to the collector. Hopefully most of you are at least somewhat familiar with it, but we have different components responsible for different part of the pipeline. So we have receivers, which are kind of the first touch point in the collector. Then we have processors, which can do some sort of processing of the data. And then we have exporters when it's coming at the other side of the pipeline, and then we're sending it to our observability backend. So as I said, receivers are kind of the first touch point where the data is coming in. And in this step, the data will be translated or transformed. I guess translated is a better version, a better term, from the protocol or from the format of the client to the actual representation that is used in the collector. This is called pipeline data. You can find it as P data. And so this is also where the decision which temporality to use comes into play. So obviously, it might not be possible to choose temporality, because if statsd gives you just the delta values, you have to use the delta temporality. On the other hand, if you have the cumulative values, you need to translate this as a cumulative temporality. So this is all where the receivers, which come into play, they take care of this, and they then translate this into the temporality that's understandable for us within OpenTelemetry and within collector. Obviously, this is different if you use the OpenTelemetry SDK, the kind of native way to send data, because then it's kind of translated one-to-one. If you use Delta temporality, then it can be translated also to Delta temporality in the pipeline data format. Moving on to processors. So processors, as I said, with this we can do some manipulation of the data points. I think there are 3 processors that can be of particular interest to people who are working with temporality, or who are thinking about how temporality works in collector. And it's the cumulative to delta processor. This one is usually kind of bundled or thought of together with the delta to rate processor. So the first one allows us to simply take cumulative values and turn them into delta values. And usually then this can be piped into the delta to rate processor that can then give us directly rates as gauges. So you can get the rate values or the rate representation directly from those cumulative values. So you can use these independently or both together. We'll also talk a little bit about when you can use cumulative to delta by itself. And transform processor, this one is, I would say, requires more, I don't know if expertise or more. It gives you more power, so it requires more knowledge or paying more attention, because this processor uses the OpenTelemetry transformation language, which is like language within OpenTelemetry that makes it possible for you to define certain transformations of the data within the OpenTelemetry. So with this, you can also manipulate the aggregation temporality of those data points. There are also some helper functions that are part of the processor, like, for example, converting gauge to sum, where you can then change monotonicity or aggregation temporality. But you should take caution when you use this one, because it doesn't prevent you from doing some unsound transformations or doing something that goes maybe against the specification or against some conventions. So I would recommend to look at it only if you have very specific use case. Lastly, when exporting to your backends, and arguably this can be one of the decisive factors when you're also looking at whether to use delta or cumulative temporality. So we can split this into 2 parts. On one hand, we have exporters, which are at the last stage of the pipeline. Again, we're translating the pipeline format back to the format that we want to output this in. And here we need to be mindful of how the exporter will translate the data. And the caveat is that not all exporters will be able to transform all of the data. I think good example, I think right now is the Prometheus remote write exporter that is not handling all of the data points with all the data points with delta temporality, and it might drop some of the data. It will give you warnings or errors, but you need to. So if something like that happens, you should be aware of that, and you need to pay attention to that. And like the other side of the coin is then your backends, whether you're using either you're running your own solution or you're sending the data to your vendor. I think you should be also aware how the data ends up on the other side of the pipeline. I think here it's good to check either documentation or check the documentation of the tool you're using or your vendor, because some vendors might support or might prefer data that is provided to them with delta temporality. Others might prefer cumulative and so on. So again, it's like important to understand what happens once the data lands in your backend. And here, if you're interested, you can also take a look into the spec. There are some guidelines how the transformation happens, especially with delta to cumulative, because in the end, when we keep sending the delta values, they need to be aggregated somewhere in the pipeline. And if this happens at the end of the pipeline in your backend, it's good to understand how this transformation occurs. And also, interesting one can be to look at how OpenTelemetry protocol is transformed to Prometheus. There's also certain guidance in the spec. For example, Grafana Mimir, which supports ingestion of metrics in the in the OTLP format, and then translates it into Prometheus, which is like native to Mimir. So they specifically refer to this guidance. So that can help you understand, like if you send some data points with delta temporality, you can gain an understanding of how they will be transformed and how will they end up on the other side. So just a short conclusion, I think there's like no perfect end-to-end solution. So if you're using one or the other, you kind of, as you go through those different steps in the pipeline, it's good to think about what happens with those data points and how they will end up on the other side of the pipeline. Especially, it's especially good to pay attention if any data can be dropped, and when reasonable, you can opt to transform to delta, whether this is because your backend prefers delta, or whether or you want to do some further processing of the data points, so you go from cumulative to delta to rate. And I think that's where we ended. Thank you.